Hey everyone, I'm really happy that you made it here. I had my doubts whether I am going to make it here, but in the end, cooler heads prevailed, and here we are. So maybe I'll just go on with the formalities. My name is Karol. I'm a software engineer, and I work at Upside. And today I wanted to talk to you about nightmare neighbors, and maybe that title sounds confusing without the subtitle. But I don't mean the guy that lives next door to you. Even though those kind of neighbors, they can also cause you to lose quite a bit of sleep. And just to make it a little, oh yeah, let me take this as well. And we're gone. Yeah. Just to make it a little less vague, maybe I'll demystify what I mean by neighbors. And I mean the multi-tenant application pattern. So maybe just to fill the waters around here, by a show of hands, could you tell me who here had previous experience with such an architecture? Yeah, so quite a lot of people. I hope you guys will serve as sort of fact checkers. I also hope that maybe you will also learn something today. But in the end, this presentation really assumes very little previous knowledge about this pattern. So maybe I will begin with a small introduction. Multi-tenancy is a pattern in software development where a single instance of an application serves multiple clients. And we can visualize it on a graph or a diagram like this. So in this case, users should probably name something different. This is by users on the slide, I mean customers, so businesses that use our applications. So these are the tenants for which we will separate data. And we can confront this pattern with the, let's say, traditional approach. Maybe traditional is a wrong word here as well, but the single tenant. So as opposed to multi-tenancy, here each of those customers, clients, has a separate application of instance of our application. And you guys are probably able to tell the difference between those two slides. But multi-tenancy in general is about creating an illusion for the users, so for the customers, that those two are actually maybe not equivalent, but we want them to make them seem the same. So we really like the clients to feel that, hey, I'm the only one using this application is just for me. And I'll quickly go over why would we even do that, and I think there are three main reasons. First of all, the setup is much quicker. So if we have multiple clients, then spinning up a new instance for each and one of them is going to be very, very costly and complicated. Also, maintenance is something that's going to be really, really unscalable if we use the single tenant application pattern. And also the cost. If we have just a single tenant using a single instance, then we really run the risk of underutilizing certain resources and just not getting our bang for the buck that we pay for the infrastructure that runs our application. And immediately we can see the pivotal concern in this pattern, which is how to partition the data, so how to actually isolate the tenants. Because this is something that our reputation as a company really relies on. Our main responsibility is to create this isolation and do not allow leaks anywhere to maintain this illusion that I mentioned even further. So our pivotal concern should be, how do we ensure that the data is separated and it's leak-proof, so there's no way to leak the data between tenants, which is especially important if our clients are enterprise, then this situation is really unacceptable. And there are multiple ways to do that. There are three main levels, let's say, at which we can separate the data. And I will go through them one by one, and maybe we'll go into some smaller details in each and one of them to really illustrate what are the advantages, so pros and cons of each of them. So the first one is row-level partitioning. This is something that we do almost every day because the idea is super simple. Each record in the database has a tenant assigned. So the records themselves, they know to which tenant they belong. So this is a super simple concept that we use in relational databases all the time. And immediately we could start to think of something like this. So we'd have maybe a tenants table in the database that then have users, for example, and then users have some other relation. And in our minds, this would be probably correct because this schema is normalized. So users and tasks, it doesn't really immediately make sense to store the tenant in both of them. But I would really advocate to use something like this. So maybe denormalize the database a little. Because as they say, you normalize until it hurts and denormalize until it works. This approach really makes it simple to work with the data in a practical manner without having to refer to several relationships along the way each time. And I kind of extracted a standard implementation of this pattern from all the implementations that are out there, so most gems that cover this topic. And this is not really perfectly named. Don't pay too much attention to the details, as Nick would say on Friday. This is all senseless, but the idea is there, in my opinion. So to achieve this partitioning, we can use default scopes. So just not to have a where clause in each and every query, we can use a default scope, which will scope the tenants or the records to a particular tenant. And oops, yeah. And we can handle certain conditions in the scope as well. So for example, we can handle tenants not being set at all. And in the end, what we want to achieve is having this where clause. So this is what the whole approach hinges upon, that the application actually injects the where clause in all the relevant queries. We can take a little detour from the partitioning because here I touched upon two topics which should be covered, in my opinion. And they are not really that complex, so we can go over them immediately. So how to actually extract the tenant? And there are multiple ways. Each depends on your particular use case. There are advantages, disadvantages to each and one of them, but you can just extract it from the host, maybe the first, last subdomain, from the path itself. So maybe you have like a slash, I don't know, and the organization name, and also the header, which is often used in mobile implementations. And then how do we actually store the current tenant? And there's really no standard way. All the ways hinge upon the thread current method or the thread current object, because we really need to store the data in each thread separately. You can have just like a global singleton. And some implementations use request store to do that, which is like an older gem. There's also something in active support natively, which is called current attributes. This is basically a per request singleton, which can help us to achieve this. So just to give you an example, we can have a per request singleton called current, which will have the tenant attribute. And we will populate that for each request. We can also populate that either in a rack middleware, maybe you can also populate that in an application controller. Then we will just inherit from that base class. And this attribute will be accessible in our code. So as you can see, this is pure Rails. We don't need special infrastructure to implement this. This does not impact the deployment process at all. And there's also very low overhead of creating tenants, which is probably the, sorry about that, which is probably the most important point here, that creating new tenants with this approach is very simple. It just boils down to inputting a record into the database. So whenever we have a situation or a use case where the tenants are much more maybe granular. So you can just create a new tenant maybe by registering. So you can have a lot of low-value tenants in the database. This is probably the way to go, because the overhead of creating a tenant, also storing them, is super low. And the only caveat here is that the application is fully responsible for the separation. So we need to make sure in the application that all the requests are scoped correctly. And also the validations, because whenever we use, for example, validates in our model, we don't really want to validate uniqueness of a record globally in the database. We always want to scope it by the tenant. So we want, for example, it to be unique, but only in the context of a single tenant. And we can kind of offload this responsibility that rests on our shoulders by using existing implementations. So there are gems out there that implement this exact behavior. So for example, access tenant or active record multi-tenant. And these are subject to peer review, so people use them. There's really no point in re-implementing the wheel, or reinventing the wheel, sorry. So we can really take advantage of someone having done that before us. But sometimes that's not really enough for us. In some scenarios, we really want to have the data integrity, like put more emphasis on separating the data and focus on integrity. So this situation where we forget a where clause, for example, is going to be much more impactful on our business. And we really can't handle that. Because the issue here is that this approach fails by default, or maybe not fail, but it leaks by default. Whenever we forget the where clause, then we'll just get the data that was not supposed to be sent. And the issue here also is that this is super simple. We really like this to be our database scheme, because this is understandable. It's super easy to maintain, but we somehow want to make it more robust. And here we can use a mechanism called row-level security, which is a mechanism in database management systems that allows us to restrict on a per-user basis or a per-session basis which rows can be returned or inserted, created. So there's a mechanism in the database themselves that can help us to filter the data. And just to give you, some example how that works, you can enable row-level security per table by using the enable row security clause or the command. And then we have to define policies for those tables. So in this example, let's say we have the users table that I showed previously, and we want the users to be scoped by tenants. So we want to always explicitly say that which tenant we are and which data we want returned. So in this case, you can see that there's a function or a comparison which says that we only want only want records where the tenant ID is equal to some current setting. And that current setting is a session parameter which will be responsible for setting for each request. Yeah, apparently I even made it easier. Yeah, and there are also, there's a small thing to remember here that this mechanism is also not applied to every user in the database. There are certain users that are exempted from this behavior. So for example, super users, table owners, and roles that have bypass row-level security set. So we really need to make sure that our application is not using one of them. So obviously we don't want to run our production database as the super user, but we probably are the table owner usually, because migrations create tables, etc. The role that we're using is able to create databases and tables. So here we need to make sure that we, for example, this is the simplest solution, that we force row-level security. This basically removes table owners from this list. So now the table owner themselves, they can't even, they will also be subject to this mechanism. And here you can see that we kind of shifted the responsibility. So as before, we had to input the where clause for each request. Now it's a little simpler. So now we just want to set the database session parameter once, and then everything will fall into place with that mechanism. So this will be the area of error will be much smaller in this case. And the way we can do that is to create some switch function, which will set this session parameter. So in this case, I named it app current tenant ID, but this is arbitrary. This is just to demonstrate the mechanism. We will yield the block, so we want to use this to wrap some behavior. And it's super important to also reset session parameters in Rails because of connection pooling and the connections not being actually closed. And session and connection are kind of synonymous in the sense that the session parameter actually lives as long as the session, which is the connection. So Active Record doesn't remove connections because it's inefficient. So if we don't reset it, then someone can reuse a connection which will have some garbage in it. And we can potentially leak data that way as well. And we can use it as a rack middleware. This is how most implementations deal with that. So we can create some rack middleware, which will extract the tenant, which we already know how to do. And it will use this to call the entire stack that's further down below, but wrapped within this switch. Yeah. And here we have this little distinction that whereas using where clauses leaked by default, this fails by default. So if we don't explicitly say which tenant we are, then we won't get the records. So if I don't say that I'm tenant 1, for example, I will just get nothing or get an error that I used a session parameter that does not exist. So does that mean that we solves all our problems though? Definitely not, because as you can imagine, this introduces some form of implicit state, whereas previously it was also stateful. We had to store this current tenant somewhere. Now it's much more veiled. Now the state is actually embedded within the connection. So it's a little like shady, let's say. And historically, this mechanism also had some performance issues. Most of them are solved, I think, since Postgres 10, in the case of Postgres, in this case. But this, you can imagine, it will impact the performance of our application because it has to evaluate that little condition and only return rows for which it returns true. So there is some overhead, definitely. And there's also like a caveat here that whereas it will fail by default if we don't set a tenant, you can imagine a scenario where we set a tenant and then leak that somewhere further down the line. So like I mentioned, for example, with the connections, maybe we'll reuse a connection that already had a tenant set, and this will lead to some undefined behavior, probably leaking data. And are there scenarios like that out there in the world? And definitely there are. So whenever we scale our application, for example, we have multiple replicas, then we really probably want to invest into some form of external connection pooling. In the case of Postgres, this is usually done via PG bouncer, which will limit the number of connections to the database. It will deal with idle connections, so this will definitely improve our throughput. And there are multiple modes of such pooling, but probably the most common one, the default as well, is transaction pooling, which is, I think on average, it yields the best results. And what it means in a nutshell is that instead of connecting to the database directly, our application will connect to the PG bouncer pool or whatever else tool that we use here. And on a query basis, so whenever we create a transaction, a new connection from the pool will be allocated by, not allocated, but will be assigned to that transaction by the pooler. So for example, we set the current tenant to 0. And since everything is a transaction, basically, even something like this will be assigned to a connection that is managed by the pool. And there's no guarantee that when I now select something from the database, that I will have the same connection as before. So now you can imagine the blue connection having another tenant set. So this is just a small caveat, but something that definitely you should keep in mind. Maybe even if you, I don't know, migrate existing code bases via a mechanism like that, that sometimes there are things that you have to remember that are completely external. And that brings us to schema-level partitioning, which is, let's say, the next level. Here, the approach is a little different. So instead of having rows that know which tenant they belong to, we have schemas in the database. So schema is basically just a set of tables, like a namespace, basically. And instead of having a tenants table, which then has relations to all them, and instead of having the tenant ID in each of the tables, we just have schemas that are namespaced, and inside those schemas, tables that are separate for each tenant will live. And it uses actually the exact same mechanism as row-level security. It works via the search path session parameter, which we can use exactly the same as we used row-level security. So we just set search path, and then we have to set it to something else. For example, reset it to the default, which is user and public, or maybe reset to the previous one, which is something that a lot of the implementations out there use. And this is very low effort. So like I mentioned previously with migrating existing code bases, this is very transparent to the entire application. So there are very few things that we can manage, configure, and it's really easy to migrate something to this approach. So we just need to scope them by the namespace, maybe move some data around, and the footprint of that solution on our code base, it shouldn't be really that much. But it definitely has a lot of drawbacks. And just to give you a few, the migration process is going to be completely custom. So Rails can't handle migrations like this. It only migrates let's say the public schema. And so we have to invest into a process that's going to be a little custom. And we have to make sure that the migrations will work for every tenant in the database. So there might be failures somewhere in the middle. Creating new tenants is much more expensive. We have to create a new schema, we have to migrate it. So the footprint is much higher. Whenever we have tenants that we don't really care about, or maybe these tenants are not really critical to us, and there's a lot of them, they are going to have much bigger impact on the entire system. Backups are much harder. This is something that Heroku, for example, this is why Heroku advocates against this approach. So they actually have a little snippet in their documentation where they say that this approach makes it really hard for their backup tools, internal tools, to be efficient. So definitely something to keep in mind. And also, you have to manage shared and tenant schemas, which is something that's really use case specific. But we have this notion of a public schema where the data is shared, and also the per tenant schemas. So you have to sort of balance the two. And also, the users, the original authors of a gem in Rails called apartment, which was the de facto standard implementation of this behavior, they themselves said that in the long run, this approach didn't work for them. I think the post that they posted is inaccessible right now, so I can't really quote as to why, but definitely it's telling that someone who was responsible for this has thoughts like that. So that brings us to the next level of partitioning, which is very extreme, and it's database level partitioning. So now for each tenant, we'll have a completely separate database. And this is where certain things are not that clear-cut, because database, schema, they can mean different things depending on the context you're in. So for example, for MySQL, database and schema are pretty much synonymous. So all the things that we said previously apply. And in Postgres, switching databases requires us to re-establish the connection. So we can't just switch databases. We have to create a new connection pool in terms of, in the context of Rails. And apartment actually, so the gem, which was the de facto standard for things like this, it had this feature where you could do re-establishing new connections for each tenant. And it looks something like this. They just had a previous connection, which they remembered. They established a new connection to the new database. And then at the end, they established connection to the previous database. And yeah, I forgot that I had this. Yeah, and here we have a weird issue, because either I don't understand the goal of that approach or why it exists in the gem, but it really doesn't work at all. So there's an issue here that in the long term might be a little elusive. So you can imagine just jumping right into multi-tenancy, maybe creating a little proof of concept to test things out. And you see this gem apartment, and you just plug it in and start using that. You want to test the database, per database connection switching. And now it's kind of, it works. And you may seem that it works. But actually, while the connection pool itself is thread safe, so whenever a new thread wants a connection, this is completely thread safe. Just re-establishing connection for a model, especially a model that's used everywhere, is not thread safe. So each connection or each thread will actually register that change. So whenever we use a fork server, for example, Unicorn, we might not even run into this issue because there's only one process. So and there are no threads that can clash. So we may not even notice this issue. And in threaded servers, for example, Puma, under very low load, or if you have multiple workers, then we also can, just by chance, never notice. And that's an issue. So it's an extreme case, but it has some merits, I have to admit, because having unlimited control about where the data is coming from and where the database is, so we can have like arbitrary connections, it's really powerful because it allows us to, first of all, scale it much better, because we won't run into issues where we can't scale vertically the database server anymore, and it's just starting to unravel. And it also allows us to be compliant with stuff like, I don't know, maybe HIPAA or PCI or the data sovereignty laws, where we need to store the data in a particular region. For example, for European companies, maybe in Europe. But so these are the lessons which we can get from that. And this is basically horizontal sharding, which means that we have multiple databases, but they have the same schema. And this is actually natively supported in Rails since version 6.1, and actually can be used to scale multi-tenant applications natively. So just to give you a little example, sharding is done by just defining the databases in the database.yaml file. So here we have a primary in a shard, and then we can specify that our records connect to those shards, which we defined in the database.yaml. So here we'd say it connects to the primary and primary shard 1 shards. And then we can switch the shard per tenant. So whenever there's a request, we will select the shard which we will use. So now we can separate the tenants arbitrarily, however we want, and store the data in multiple places, or one place per tenant. And this is actually correct in this case, because now we have separate connection pools. So there's no more of this issue that I mentioned. And there's way more to this topic in general. So now that I mentioned shards, there's the topic of balancing shards. So you have to optimize in the long term, whenever you have multiple or a lot of tenants, that the data distribution and how they are routed really matters to the overall performance. For example, if you have tenants that have very similar usage patterns, they all have spikes at the same time, we can exhaust the resources of our system and lead to crashes. This is called a noisy tenant, a noisy neighbor problem, where tenants in the system can impact other tenants. So separating them in a smart way is actually really critical. And there's also all the application level tools that we have to take care of, which I won't go into details since this is more use case specific. Today I wanted to maybe lay the groundwork of this approach because it's very generic. This is something that you will have to know regardless of a use case. But for example, handling sidekick, delayed jobs, etc., creating Elasticsearch indexes separately for each tenant, this is something that you also have to take into account when deciding which approach to use. Maybe in this case, it's not even that coupled with the approach. So I really struggle to pinpoint a specific lesson from this talk. I hope I didn't give the impression that I'm winging it too much, but I definitely was. So I think it all comes down to a specific scenario. So there are business requirements, growth plans, legal stuff, which we have to take into account, and that all impacts the decision in the long term. So I don't think there's an easy answer to the question, which one should I use? And if I have to decide on one thing, which I wanted to throw out there, is that you should decide early which approach you want to use, because selecting, you can lock yourself into a particular decision and then decide, that it wasn't really the good approach. So if you make a good informed decision as early as possible, it can really save you time from rework and minimize, losses. So on that note, I wanted to thank you all for coming, and yeah, I think I managed to do it in time, and I guess that's it. Yeah, and obviously questions, if any.
So which of those solutions would you recommend if you need to sometimes have aggregated computations?
If I need to what?
You need to sometimes aggregate per multiple tenants.
Oh,
because that's the usual scenario for staff members and admins.
Yes, definitely. So both the schema level and row level approaches, they both allow you to do exactly that. Because you can just reference cross schema. You can prefix the tables, for example, tenant a dot table name. So you can freely join this data as you want. Obviously, with row level approach, it's much easier. It just comes down to extending the where clause. But splitting it by schema also has has different issues if you want to aggregate data. Because, for example, while it allows you to easily backup one tenant, backupping everything, like I mentioned, becomes a problem. So, so if I had to decide on one approach which I would design as default, because it handles most stuff, then probably the row-level approach is the way to go in most cases. I think Shopify, which is one of the most recognizable multi-tenant architectures, they use this approach. Also Salesforce. So it's definitely battle-tested and scalable.
Good, thanks.
Yeah, hello, Karol. Thanks a lot for your presentation. There's one thing I am a bit wary about. So when talking about row-level multi-tenancy, you mentioned a few times that you should be a bit wary with where clauses. But I've just checked the documentation of acts as tenant and did a small simulation, and basically if a model is scoped to a tenant, and you try to do any active record queries on it, then you'll get an error that no tenant is set. So if you use an active record but not the database directly, you won't kind of have this where clause problem.
Yeah, that's definitely a good point. It was also sort of on on the slide when I raise an exception whenever a tenant is not set, it's a similar approach, but it's if you are perfectly confident that the application is the only thing that will access the data and everything will go through that default scope, then it's not a problem. If it was a problem, then this wouldn't be a viable option long term. But it's more about managing all the things on the side. So definitely, I don't want to give the impression that this is like an actual risk that you take every time you use a row-level approach. It's more of something that you need to always remember about, that this is actually hinges on the workloads, and whenever you have to go around this mechanism, then that might be a problem. I don't know if that addresses your statement correctly.
Yeah, that's a valid point. I also liked what you said about like the database, for example, being accessed not just by the application but by other stuff.
Could you repeat that, please?
Yeah, I said that you've got a valid point, and it makes sense if like the database, for example, is being accessed not only by the Rails application but by other services.
Okay, yeah, definitely, yeah. That's also my point. So I guess we're on the same page. Thank you for the question.
Hi, Karol. Thank you very
Hello.
much for the talk. When you told us about the row-level version, you also said that you have to scope everything by this tenant. You have to remember about the workloads. But from the database performance perspective, it seems to me that if you have to have everything scoped by the tenant, and also like unicity is scoped by the tenant, yeah, that was the point, sorry. When unicity is scoped by the tenant, you kind of also have to have all the indexes scoped by the tenant, right? Is that the consequence?
It is a good question, whether you mean like multi-column indexes instead of single indexes.
Yes.
Not necessarily. I don't have a good answer to this. It would definitely help if you scoped it, at least intuitively, I think. We'd have to check. But also on the note of performance, indexing definitely helps. There's also partitioning inside the database, which you can also use when using the row-level approach. So you can physically partition the data by tenant ID, for example, and then it can do partition pruning, which probably will speed things up. But that's I think it's very long down the road that you actually have to worry about stuff like that. But really a good point about the indexes. This is something that would be good to include up in a presentation like this, I think. So I can check and go back to you, if that's okay.
Thank you very much.
No problem.
Okay, I have a question. So the indexing thing, it may or may not help, because for ranges it would help, but for looking up specific IDs it might actually make it slower. I think because you mentioned Elasticsearch before in your talk, and I think one thing that may not have been covered was, what about read models? Because even at the database level, you can create custom read models, right? So the database, I know this is not particularly popular in the Rails community, but theoretically, you could be using like procedural callbacks at the pSQL level to create read models that are per tenant, and then have your models directly access those.
Okay, I don't know if I know read models that well, but you mean maybe like a view?
Yeah, like database views.
Yeah, definitely. That's definitely something that I encountered. I never actually worked with this approach, but that's something that's really quite interesting. Is instead of like having all this denormalized, data that I showed, having maybe materialized or not materialized view, maybe materialized would be based in this case. It's also another approach to separate it but without really separating it. So it's an interesting question as well. I definitely get what you mean, but I don't know how to address that. Maybe is there something that you're looking for in particular that I can help you with, or was that like a remark?
I think that was a remark, not a question. I apologize.
Yeah, I mean that's definitely a valid remark. So, so thank you for making the presentation complete.
Last question, anyone? Okay, no questions. So thank you, Karol.
Thank you so much.